Okay, so our last section, chapter 1 is 1.6. Okay, it's on different operations we can do to functions. Okay, so it's basically like taking two functions that we already have and combining them in different ways to create a new function. Okay, what we have to be careful with when we create new functions is you're messing with the domain and range. Okay, so that's going to be a big part of what we do today. Is once we create new functions from ones we already have, how does that affect the domain? How does it affect the range? Okay, the four basic ways you can combine two functions are very simply just taking the two that you have, adding them together, subtracting them, multiplying them, or dividing them. Okay, so we'll go through an example of each one of those. All right, so I'll give you two basic functions, f of x, g of x, and we'll create new functions by doing these four operations. Okay, when we do this, if we can combine like terms or simplify something, we will. If we can't, then we can't. Okay, we just only combine and simplify what you can. All right, so John, do you think you could tell me what f of x plus g of x would look like if I wrote that down?
I would say it would be like x squared plus the square root of x plus 1.
Yeah, that's all you can do. There's nothing you can combine. Okay, so this is a brand new function, x squared plus the square root of x plus 1, and it was created by taking two functions we already had and just adding them together. Any questions on how I found f of x plus g of x? All right, let's create another new function. This time we'll take the two that we have and divide them. So Luke, what would that look like if I wrote down f of x divided by g of x?
X squared over the square root of x plus 1.
Yeah, okay. Unless we're going to get the square root out of the denominator, which we could, but I'm not concerned about at this point. That's the answer. Okay? X squared divided by the square root of x plus 1. Okay, and they give you more examples on page 58. Okay. Questions on that? Okay, so creating new functions isn't really that hard, just to take what you have and combine it different ways. What does get tricky is figuring out, okay, what's the domain that I started with, and now what's the domain because I combined them together? Did it change? Sometimes it does. Sometimes it doesn't change at all. Okay, we'll go through that. All right, let's take a look at f of x and g of x. What's the domain for f of x? What numbers are you allowed to square? Oh, you can square any number that you want. Okay? So the domain of f of x is all real numbers. How about g of x? What kind of numbers are you allowed to take the square root of? Or you can think of it as what kind of tell me what numbers you can't take the square root of if you're not sure. Luke? You can or you can't? Yeah, so we're not going to deal with square roots of imaginaries. What else? Yeah?
Negatives.
Yeah, negatives. Okay, we can take the square root of anything that's not a negative number. So I would want to avoid this being negative. 0 is okay, but negative is not. So what would the domain of g of x be? I'd have to pick all numbers that are greater than or equal to... Yeah? Yes, greater than or equal to negative 1. If you pick any number that's negative 1 or bigger, that thing I circled will never be a negative. Okay, let's take a look at this one. Okay. I know the domain of the top was all real numbers, so I don't really have to worry too much about that. But I got to be careful with the bottom. Okay, we said before that the domain of that square root function was all numbers greater than or equal to -1. But where is the square root function now? And because of where it is, we now have to be careful of something else that we didn't have before. Yep.
The denominator can't be 0.
Right, now the square root function is in the bottom of a fraction. So not only can what's under the square root not be negative, but this entire thing can't be 0. So can I still pick numbers that are -1 and higher? No. Now I can only pick numbers -1 and higher, not including -1. Okay? Because if you pick -1, you're going to have the square root of 0, which is okay. But then you're going to have something divided by 0. Can't do that. So this is an example where the domain changed because of how we combine the functions together. So basically the idea of when you create a new function, okay, the domain of the new function is all values such that x belongs to both of the original functions. Okay? And of course, with division, you also have to make sure you never divide by 0. Okay, so the way I usually explain it is, let's say you had a number line. And I'm just going to make up a domain. Let's say you had a problem where the domain was all numbers greater than or equal to 0. Okay, that's all numbers greater than or equal to 0. And let's say you had another function that the domain was all numbers greater than or equal to 2. So when I combine the red function and the green function together, I need to pick numbers that are in both domains. So where's the overlap here? Where are the numbers that would be in both the red function and the green function? 2 and up. Yep. Okay, so that would be the domain when I combine them together. I have to pick numbers that are in both of the original functions. Okay, if I pick the number 1, well, that would work in whatever the red function is. But 1 does not work in whatever the green function is, for whatever reason. Okay, so you've got to pick numbers that are in both. Okay, and as we just saw in the last example, make sure you never have a number in the domain that would cause you to divide by 0. Okay, so these are really the two important things when you're trying to figure out domain that you have to look for. Okay, and we've said them over and over. Make sure you never take the square root of a negative. Make sure the denominator never equals 0. If you check those two things when you're finding domain, you'll be all set. Okay, then when we talk about range, range is a little harder to visualize, I think, in your head. So we'll use a graphing calculator. Bless you. We'll use a graphing calculator to help us out with that. All right, so we're going to take these two functions, f of x, g of x, and we're going to combine them in different ways. And once I combine them, I want to figure out the domain. Sometimes it won't change from the original, sometimes it will. All right, let's start with square root of x plus 3. What would be the numbers that are in the domain of f of x? What are you allowed to plug in for x in the top function? -3 is one number you're allowed to, yeah? And what? Yeah, every -3 and everything above that. So the way we write it is bracket on -3, that means including -3, up to infinity. And what kind of symbol do I always put on infinity? Parentheses, okay? Because bracket means you can actually reach that number, you can use it. Infinity is not a number we can ever reach. So that's why we always put a parenthesis on infinity. Okay. How about the domain for g of x? I could pick numbers from a certain value and on
I
from
have
there.
a question about the bracket. So
Mhm.
if you were to put the parentheses on the, or to the left of -3,
Mhm.
does that mean you couldn't use -3?
That means not including negative
Not-
3.
Okay.
Okay, so that's like negative 2.99999 and up. Okay, so if you put a parenthesis, that's not including. Bracket means including. Okay, how about the domain of g of x? James?
Greater than or equal to 2.
Yep, and how would you write that as an interval?
Bracket to infinity.
All right. So now let's take f of x and g of x, and we're going to add them. Okay, because they're roots, there's really nothing we can do to combine them. So just literally write that down. F of x plus g of x. Okay, so there's the function. And now I want to know the domain. Okay, so remember, the domain has to be numbers that I could plug into both. So does anybody see where the overlap would be here? From 2 to infinity. Okay? Yep, infinity and beyond. So yeah, you can plug any number from 2 to infinity. Okay? Does everybody see why you couldn't use, say, 0? Yeah, it would work in the first one, but if you try it in the second one, you've got 0 take away 2. That's the square root of negative 2. Okay, so you've got to pick numbers that work in both, and from 2 to infinity will. All right. How about, John, what would it look like if I wrote f of x divided by g of x?
Do the square root of x plus 3 on the numerator, and then the square root of x minus 2.
All right, good. So that's my function. And now I want to know the domain. So the domain is already limited to at least between 2 and infinity, okay? Because those are the only numbers that work in both. But is there anything else I have to be careful of now because of how I combine these functions? Yeah?
The denominator can't be 0.
The denominator cannot be 0. And what number would make the denominator 0?
2.
2. So that means I can no longer use the number 2. So how would I write my domain showing that 2 is no longer part of it? Denver?
Use a parentheses.
Yep.
2.
Yes. Okay, so that's my domain. Any number from 2, not including it, up to infinity. Okay, any questions on that? All right, let's take a look at this one. It says, find and graph the domain and range of f of x divided by g of x. Okay, so f of x divided by g of x. I think we can do the domain. We don't really need a calculator or a graph to do that. What kind of numbers are you allowed to take the absolute value of? You can take the absolute value of any number. What kind of numbers are you allowed to substitute in for a variable, like just x? Anything. Now, because of how I combine these functions, is there anything else I got to be careful about? Right, I can't use 0. All right? 0 is the only number you are not allowed to use. All right, so the way we write that you can't use 0 is like this. Pick any number from negative infinity up to, not including 0, or you can pick a number from 0 to infinity. Again, not including 0. Any questions on that? So any number between negative infinity and 0, not including 0, or from 0, not including again, to infinity.
Does that little u mean or?
Yes, it means or. Yep. It actually means union, but yes, or. Same thing. All right, let's see if we can figure out what the range is. Let's plug in like the number 5. What's the absolute value of 5? Divided by 5. You get 1. How about, let's try 12, absolute value of 12.
12.
Divide by 12.
1.
1. When you plug in any positive number for x, you're always going to get 1. Okay, let's try a negative number. Let's do negative 3. What's the absolute value of negative 3? 3 divided by negative 3. Negative 1. So let's graph it, but really what's going to end up happening is you're only going to get 2 numbers for y. Okay. You're only going to get a 1 or a negative 1. All right, so we've got math number, absolute value of x divided by x. Just do zoom 6. So you can see anytime you plug in a negative, you get a y value of negative 1. No matter what positive number you plug in for x, y is always positive 1. And of course, if you try to do 0, it doesn't give you a y value because you'd be dividing by 0. So that's what your graph looks like. Question? Just stretching, Adrian? Just stretch. Okay. Any other questions on that one? Okay, so kind of a weird looking graph, but that's what it looks like. All right, so another way we can take 2 functions and put them together, just besides adding, subtracting, multiplying, and dividing, is called composition. Okay, composition is a little bit more advanced way to take 2 functions and put them together. Okay, so rather than try to explain it with just words without an example, I'm going to just show you what it is with an example. Okay, so I've got 2 functions, g of x and f of x. And I'm going to find this. Okay, this is called a composition. And the way you pronounce that is g, and you pronounce the parenthesis as of. G of f of x. Okay, g of f of x. Okay, and before I do the composition, it might be simple if I just show you with a number. What would you do if I asked you to find g of 4? What does that mean you do with the 4? Yeah. You take in function g, you look at what's in parentheses, and you change all the variables to what's in parentheses. Okay? So in this case, I would plug 4 in for x, and then take the square root of 4 and get 2. Okay? If I said to plug in g of 16, take 16, take what's in the parentheses, plug it into function g, and then get the answer. Okay, now we're going to do the same thing, but we're not going to do it with a number. We're going to take what's in parentheses, and we're going to plug it into function g. All right, so I have g of, what does it say up above f of x is equal to? Hey, f of x is x squared plus 3. Okay, so I just changed f of x to what it says f of x is equal to. Now, just like when I had a number, I'm going to take what's in parentheses, and I'm going to plug that into function g. Okay, so look at function g. Everywhere you have a letter in function g, change it to what I said to plug in, okay, which is not a number this time. It's x squared plus 3. So anybody think they could tell me what I would get if I plug x squared plus 3 into function g? Yep.
X plus the square root of 3.
Can you tell me before that step?
X squared, square root of x squared plus 3.
Yeah. And it turns out when you have addition under a root, you cannot simplify it. Okay? You can't take the square root of the x. You could try, it doesn't work. Okay? The only time you can simplify what's under a root is if you had multiplication. Then I can say the square root of 4 is 2, square root of x squared is x. Okay, but you cannot do that with addition or subtraction. And that's it. Okay? What we just did there, that was composition. You plugged one function into the other. Right? So if we can find g of f, we can also find f of g. I'm just going to reverse it. Okay, so Hannah, I'm going to take function g. I'm going to plug it into f. Can you just remind me what function g is?
The square root of x.
Yeah, g of x is the square root of x. So now take this and plug it into function f. Okay, so in function f, everywhere I have a letter, I'm going to change it to square root of x. Okay, so I get square root of x squared plus 3. And that does simplify. What does the square root of x squared plus 3 simplify to? X plus 3. Now, what gets a little tricky is finding the domain of a composition. If I take everything else off the screen, and all you do is look at x plus 3, you showed that to somebody. You say, well, what numbers are you allowed to add 3 to? Anything. You can add 3 to any number. But the problem is this was not an x to start with. It came from a square root. And square roots have restrictions. Okay, so when we find the domain of a composition, not only do we have to look at the final answer, but we also have to look at where it came from. Okay, how was the final answer created? Because there might have been a restriction here that we canceled out when we did something. And we can't forget about it. All right, so we'll talk about that in a second. Okay, so before I talk about how you find the domain, one other way you might see composition written in your book is a little circle with a letter on each side. Okay, this is pronounced G composed with F, and it means exactly the same thing as G of f of x. Okay, I usually use this notation, but if you see G, a small circle, and an F in the book, it just means this. Okay? All right, so the important, probably the most important thing we're doing today is how do you figure out the domain when you compose two functions? And the range will follow. Okay, so once we get domain, then we can also figure out range using a calculator to help us. Okay. 2 steps, okay, to figure out the domain of a composition function. Does everybody have what's on the left? Because I'll get rid of that in a second. Okay. First thing you have to do if you want to find the domain of a composition function is look at the inside function. Okay, so in this problem, what I just circled in red, that's the inside function. Okay, look at that and ask yourself, are there any values that I need to be careful of, in this case with g of x? Okay, if there are, we're going to take those into account. Okay, when we write our domain, I'm going to use this as a starting point. Find the domain of the inside function. Okay, in the example above it, this was the inside function. Okay, so start by finding the domain of the inside function and eliminate any values you are not allowed to use. Things you're looking for, dividing by 0, square roots of negatives. Okay, after you've narrowed down the domain by looking at the inside function, then you need to look at the composed function. Okay, that's what I'm circling in green. Look at the composed function and see, because of the way I compose these, are there any other restrictions I need to be careful about? Did I create something that all of a sudden is going to have a divide by 0, and that didn't happen before? Right? Did I create a square root somehow that I didn't have before? Okay, so look at the composed function and ask yourself, is there anything else I need to be careful with? If there is, we would eliminate those values as well. All right, so just to kind of practice with composition a little bit more, and then we'll get to one where I actually have you find domain and range. I think I have one in a second. Yeah, find domain and range. Okay, let's just practice with even just plugging in a number. Okay, let's practice finding f of g of 9. Okay, so you start on the inside, and I'm going to take 9 and plug it into function g. You don't have to tell me the answer, but what does it look like when I plug a 9 into function g?
F,
Yep, f of,
F of G.
and what are you plugging in into g?
Oh, we're plugging in.
Yep,
The type thing's multiplied by 9.
careful, we're not, so this is composition. So even though we have things next to each other, it's not multiplication. It's not f times g.
So just be X plus 4.
Not quite, Nick.
X, so the square root of X.
And what are you plugging in for x?
9.
9. So step 1 is to take what you see inside the parentheses, 9, plug 9 into function g. All right? So that's f of, what's the square root of 9? 3. Now, it says to take 3 and plug that into function f. So if I do that, you don't have to tell me the answer. Just tell me, what does it look like? 3 plus 1. And now I want the answer, 4. Okay, so that's just a numeric example with composition. No variables involved in the final answer. Now let's do composition, okay, with variables. Okay, so step 1, look up what that function is and write it down. F of, okay, and Curtis, what's g of x?
The square root of x.
Yep. Square root of x. And now I'm going to plug the square root of x into function f. Okay. Somebody tell me what that would look like when I plug that in, Hannah?
The square root of x plus 1.
Perfect. Square root of x and the plus 1 is on the outside, separate. Okay, so I think we've seen examples before that when you switch them, they usually don't come out the same. F of g and g of f are not usually the same. If they are, that does mean something, but yeah, you don't have to worry about that. Okay, so now we're going to find g of f of x. John, what's f of x?
X plus 1.
X plus 1. And now, can somebody tell me what you get when you plug x plus 1 into g? Yeah?
Square root of X plus 1.
Yep, and this time, the x plus 1 is all under the root. So any questions on that? I didn't find the domain. We're going to do that right now. All right, so I've got 2 more. Okay, I'll find the functions because you guys did that in the last one. So I'm going to find these pretty quick. Okay, I'm going to find g of f of x. So I want g of x squared minus 1, which means I want the square root of x squared minus 1. Now, the new part is I want you to tell me the domain. Start with the inside function. Look at f of x. Are there any numbers that you should be careful with that you couldn't use in f of x? What do you think? Luke?
Negative.
Actually, negative's okay. You can square a negative number.
But then you're going to a square root, right, since f of, or g of f of x, right?
Don't worry about g yet. We'll worry about g after. For now, just worry about that inside function, just f of x. Right, so are there any numbers you couldn't use there? Ian?
There are no numbers that you could not use there.
So everything is fine. Okay? You can plug in any number you want, square, subtract 1. All right, so next step. Look at the final answer. Are there things we might have to be careful about here? Yeah, you cannot take the square root of a negative, right? So in other words, I want what's under the root to not be negative. Somehow I want x squared take away 1 to always be 0 and up. Okay, if that doesn't make sense, think of it this way. You want x squared always greater than or equal to 1. As long as that happens, what's under this root will never be negative. So what kind of numbers can I square and they come out greater than or equal to 1? Denver?
All of them except 0. Oh, square.
Yeah, 1/2 wouldn't work. Because like if I squared 1/2, I'd get 1/4, take away 1, that would be negative.
Or greater than or equal to 1.
Okay, I agree. I can take any number greater than or equal to 1. And what else? Because I could plug in other numbers that would work, like -4 squared, that would be 16. 16 take away 1 is 15. I can take the square root of 15.
Anything that's at least
-1 or
less.
less, smaller. Yep. So the domain is anything that's bigger than 1 or anything smaller than -1. Okay, that's a little tricky. And that's how you write it. Always put the smaller thing on the left, put the bigger thing on the right. -infinity up to -1. Okay? That's my domain. And if you graph it, you can always double check. So what should happen here is there should be a gap between -1 and 1 where I see nothing on the screen. Because the numbers between -1 and 1 are not in the domain. Okay, so that's exactly what I see. Okay, you can pick any number less than -1 or more than +1. All right, let's switch it around the other way and find the domain. Okay, so I'll find f of g of x. That's f